All right, here we go. We're going on now to example number 3. And in example number 3, we're going to need to solve a few logarithms and simplify some logarithms. However, let's go over a few properties of logarithms that are going to be helpful to us when we're trying to solve these tamales. By the way, they have guacamole in Chile. And they have a little bit of queso. Ay, mijo. Okay, so no food right now. You know, like I'm pretty hungry right now, but here we go. So what are some properties of logarithms that are going to be helpful to us to solve these? Well, let's do this one first here. So if we have our log base a, okay, and we're taking it of 1, so log base a of 1. That right there is always going to be 0 right here. And we know that because I'm going to draw like this little arrow, which means that implies that a to the power of 0 equals 1. Okay, and then, so that's by intuition there. We know that a to the power of 0 equals 1, so that's why that's 1 right there. So that's the first kind of property that we have to make sure that we understand right there. Now watch this. If I have log base a of a, check this out. This right here is always going to be equal to 1. And that should make sense. Why? Well, look, if I write this in exponential form, that means a to the power of what equals a. Well, look, if they both have the same thing, okay, right here, right? Wouldn't x be 1? So that, because if x was 1, then that means a to the power of 1 equals a. So it should make sense that log base a of a is 1. So if your base of your log and what you're taking the log of, if these two are the same, it's always going to be a 1 right there. Okay. I'm sorry. It's always going to be what it's equal to right there. Okay, so it's going to be 1. Next thing right here. Thirdly, say if I have log base a of a equals to the power of x. Okay, so log base a of a to the power of x. What kind of rule can we make of this? Well, that implies that our base a right here, to the power of what number is a to the x? So look here. What makes sense? What number or value can I place right here? Okay, well look, if you want the right side and the left side to be equal to each other, I would just put x right there. So we can apply then that this right here equals x. Once again, it's kind of like applying rule number 2, where our base and what we're taking the log of are the same. Okay, so if these two are the same, okay, listen, if these two are the same, then whatever the exponent is, it equals x. Sorry, there, I kind of wrote that a little sloppy there, but this should be equal to x. Let me just write that a little nicer there. So this right here, this rule says that this should be equal to x. Okay? So, and then next thing right here, last rule that I want to go over with you is, say if I have log base a, and then we're taking that of x. Okay? I want you to understand something real quick here. If that's equal to log base a to the y. Do you see here how we have the same base? Okay. If you have the same base, okay, if you have the same base, log base a, basically what happens is that's the same thing as saying x equals y. So you can set these two things equal to each other. Okay. So here are the 4 properties that you must know. This guy right here. Okay. You got to know this guy right here. You need to know this guy right here. And you need to know that these guys really is the same thing as that. So this over here was just kind of like y, but really you have to know what the highlighted is. So let's go ahead now and apply now those things to the things on the left then. Okay? And let's check out what's going on right there. So let me get a different color here so we're not like bleeding in there. Okay, so let's do this. Log base 2 equals x. Oh, I'm sorry, log base 2 of x equals log base 2 of 3. which one of these properties can we apply to solve, that's what it says here, solve here, right? To solve for x. The fourth one, right? Because look, they have the same base too, so that means all I do is I just say x equals 3. And that's all you do, because they have the same base, just like this property right here, if they have the same base. Okay. So that's it. We're done. We just solve for x. Going down over here. What property are we going to use for log base 4 equals, or I'm sorry, log base 4 of 4 equals x? What is our value of x going to be then? If you look over here, what is it going to be? Well, it has to be 1, right? Look, we're using property number 2. If these two are the same, what does it always equal? 1. Hey, yeah, this is kind of like Dora the Explorer. I don't know if you've ever seen that show, but if you ever watch Dora the Explorer, she asks questions. So as I'm asking these questions, go ahead and, don't feel bad, right? All right? Just go ahead and answer out loud. Just answer out loud. So like if I say, hey, what is equal? Say out loud 1. Don't worry, your brother or sister may make fun of you, but at least you're learning, right? Okay, so this right here has to be 1, and that's because of that property right there. Okay, example C now. Okay, let's see. So if I have log base 5 of 5 to the power of x, what must this equal? Let's look at our properties again. Okay, here's our 4 properties. Yes, answer out loud. It's okay. Which one of those 4 properties would we use? That's right, Jamie. We're going to use the third property. So if our base and what we're taking the log of are the same, it's just going to be equal to the exponent of x. So look, so that means this one right here is just going to be equal to x. Simple, right? Easy. Now, part D, we'll get a little tricky here. Okay, so what is 7 to the power of? So this whole thing right here, okay, this whole thing is an exponent, okay? What is 7 to the power of log base 7 of 14? Okay, well look, if we come up, well, I mean, we really didn't write an explicit rule, but maybe if we could just think about this intuitively. Listen, if our base of our exponent right here, right? Okay, so this would be like our base. I mean, even though that, okay, that's also a base there, but if this number right here, okay, and our base of our log are the same, basically those are just inverses of each other. So those are just going to cross out right there. So basically we could just cross those guys out, and it's just going to be equal to 14 because these are just inverses of each other. And it would just be equal to 14, and that's going to be it right there. So there's A, B, C, and D, and that concludes example number 3.